A building may be designed by one organization, constructed by another, owned by an investor, operated by a facility management team, occupied by several companies, maintained by external service providers, inspected by authorities, and modified many times during its life. Each participant may use different systems, different classifications, different identities, different processes, and different versions of the same information. But they are all making decisions about the same built environment. The problem is not only that our software applications are disconnected. The deeper problem is that the traditional digital model is too narrow for the reality we are trying to manage. Welcome to the Digital Builder. I am Miguel Sanchez Miguel. On this channel, we explore how business, technology, information, and people come together to shape the built environment of the 21st century. This is not only about buying better software. It is about understanding the models behind the software and how those models influence the organizations, assets, and people that depend on them. In this video, I want to answer one specific question. Why does facility management require a new digital model? Facility management is not becoming less important. It is becoming more important. Buildings contain more technology. Operational responsibilities are distributed among more organizations. Regulatory and sustainability requirements are increasing. Information is created throughout the entire life cycle, and decisions made in one phase increasingly affect every phase that follows. Traditional facility management normally concentrates on the operational phase and on the requirements of the organization that owns, operates, or occupies the assets. That remains necessary, but it is no longer sufficient. Let me begin with an important clarification. This is not an argument against facility management. Facility management coordinates many essential responsibilities: spaces, assets, maintenance, workplaces, service providers, health and safety, energy, compliance, and the daily support of building users. These responsibilities do not disappear when we introduce a broader model. They remain central, but they exist inside a much larger environment. A maintenance decision may depend on design information. A service failure may affect contractual commitments. An equipment replacement may affect energy targets, capital planning, and regulatory compliance. An operational decision may affect the owner, operator, occupier, contractor, manufacturer, and authority simultaneously. Facility management operates inside a network of life cycle relationships. Consider one building. An investor establishes its purpose. A developer organizes the project. Architects and engineers design it. Contractors construct it. Manufacturers supply its components. Authorities approve it. An owner receives. An operator manages it. Service providers maintain it. Occupiers use it. And future teams renovate, repurpose, or eventually dispose of it. These stakeholders do not share the same responsibilities. They do not necessarily trust one another. They do not have the same access rights. They may have different commercial interests, and they do not all participate at the same time. Nevertheless, their actions are connected. A decision made by one stakeholder becomes information, risk, cost, or responsibility for another. Traditionally, we attempt to manage this complexity through handovers. At the end of design, information is transferred to construction. At the end of construction, information is transferred to operations. When a service provider changes, information is transferred again. Documents are delivered. Files are exported. asset lists are prepared, models are uploaded. But a handover is only a moment. The built environment continues changing. Assets are moved or replaced. Rooms are reconfigured. Contracts expire. Service commitments change. Organizations merge. Responsibilities move. Documents are revised. New regulations appear. We do not only need to transfer information. We need to preserve the identity, context, and relationships of the built environment throughout its life cycle. When organizations encounter these problems, the usual response is to acquire another application, a maintenance system, a workplace application, a BIM viewer, an energy platform, a document repository, a financial system, an Internet of Things platform, an artificial intelligence service. Each application may solve a real problem, but more applications can also create more fragmentation. Different systems may represent the same building differently. They may assign different codes to the same room. They may create several records for the same piece of equipment. They may separate contracts from the work and cost governed by those contracts. They may store documents without maintaining their relationship to the relevant asset, activity, or responsibility. Digitalization is not achieved by accumulating applications. It requires a coherent management and information model beneath them. Many traditional systems are organized around functional modules: space management, asset management, maintenance, contracts, projects, documents, finance. Each module serves a useful purpose, but the real world does not behave like a software menu. A building system may cross many floors. A service contract may cover many assets and locations. One work activity may involve several organizations. One decision may generate operational, contractual, financial, and regulatory consequences. The built environment is interconnected by nature. Our digital model must represent those connections. This is why I purpose a broader perspective: built environment management. Built environment management does not replace facility management. It places facility management within the complete lifecycle, stakeholder, and information context. It considers why the built environment exists, who participates in it, which processes shape it, which places and assets compose it, which information describes it, which technology enables it, which value networks deliver its outcomes, and which governance establishes trust and accountability. It asks us to look beyond one application, beyond one department, beyond one company, and beyond one phase of the life cycle. To organize this wider perspective, I use the BEM 8+3 framework. It brings together 8 management dimensions: purpose, people, processes, places, information, technology, value network, and governance. But identifying the 8 dimensions is not enough. The model must also work across the boundaries between them. For that, 3 requirements are essential. The elements must be interconnected. The systems must be interoperable. The stakeholders must be able to collaborate. These 3 requirements are related, but they are not the same. Interconnection gives meaning to the elements. Interoperability allows systems to exchange and use information. Collaboration allows stakeholders to act together. Imagine an air handling unit in an office building. In a conventional maintenance system, we may know its equipment code, its location, its preventive maintenance plan, its work history, and its assigned technician. That information is useful, but the complete management reality also includes which other assets contain it or depend on it, which areas it serves, which organization owns it, which organization operates it, which contract covers it, which service commitments apply, which activities have been completed, which resources and costs were consumed, which notifications were issued, which documents relate to it, and which accountable transactions demonstrate what actually occurred. The unit is not merely a maintenance record. It is one asset within a larger network of assets, stakeholders, commitments, activities, costs, documents, and governed transactions. That network is the built environment management reality. A new digital model does not require every stakeholder to use one enormous application. It does not require every participant to expose all information. And it does not require every organization to abandon its existing systems. It requires something more practical, a consistent understanding of the elements, reliable identity across the systems, relationships that preserve context, governance that defines authority and access, interoperability between different applications, and collaboration supported by accountable transactions. The built environment may remain distributed. Its digital representation must no longer remain fragmented. Facility management remains essential, but it can no longer be managed as an isolated operational function supported by isolated applications. It must connect with the lifecycle, with the stakeholders, with contracts and service commitments, with works and activities, with resources and costs, with documents, and with governed evidence of what actually occurred. Facility management is not disappearing. It is becoming part of something larger, built environment management. And built environment management requires a new digital model. In the next relevant video, we will look inside the information foundation of that model. We will identify the operational areas of the Bruce dataset, examine the universal asset structure, and explain how relationships and governance give meaning to the built environment information. I am Miguel Sanchez Miguel, and this is the Digital Builder, navigating the built environment of the 21st century.